Welcome to the Cosmic Savannah with Dr. Jacinta Delhaize
and Dr. Daniel Cunnama. Each episode, we'll be giving you a behind-the-scenes look at world-class astronomy and astrophysics happening under African skies.
Let us introduce you to the people involved, the technology we use, the exciting work we do, and the fascinating discoveries we make.
Sit back and relax as we take you on a safari through the skies.
Hi everyone, welcome to Season 4.
Welcome to Season 4 of the Cosmic Savannah.
How exciting that we made it here, Dan.
Yeah, who would have thought? 36 episodes so far?
37. Episode 37.
Number 37.
Yeah.
Phew.
Hey!
It's gone by in a flash.
Kind of, yeah, it has. I can't believe that we've made it this far. It's so exciting. Thank you for all of our returning listeners. Welcome back. And for our new listeners, a big warm welcome.
Yeah, and maybe we should just give a sort of brief recap of who we are and what we do and why we talk
Yeah, sure.
on a podcast. Jacinta?
Yes, well, I am Jacinta and I am a research fellow at the University of Cape Town. And I am, as you can hear from my accent, I'm from Australia originally. And I moved to Cape Town in 2018, just in time for the launch of, or just after the launch of a brand new radio telescope in South Africa called Meerkat, which is in the Karoo region, producing so much amazing science. And I'm very privileged to be able to use the data from that for my work. And this is all in the lead up for a telescope called the SKA, the Square Kilometre Array, which we'll be talking a lot about today. And I'm one of the co-hosts of the Cosmic Savannah podcast, which is just talking about the amazing astronomy coming out of the African continent, which we don't often hear about, but there really is some amazing stuff happening. And so we wanted to share that with everyone around the world.
Yeah, we're pretty psyched about astronomy coming out of Africa. If you keep listening, you'll hear that over and over again.
Dan, tell us about yourself.
Well, thank you. My name is Daniel. You can call me Dan. And I'm the science engagement astronomer at the South African Astronomical Observatory. So the South African Astronomical Observatory is responsible for all of the optical and infrared astronomy that happens in South Africa. We have our head office in Cape Town, South Africa, and we have our optical and infrared telescopes about 4 hours north in a town called Sutherland. My role at the observatory is to promote the research we do and the science we do, as well as astronomy in general. And I do that in various ways, the obvious ways, in sort of press releases, TV, radio, podcasts. And then also in some kind of new and exciting ways, I'm responsible for the construction of a new visitor center. And I've made 2 planetarium films now.
2?
2. Yeah, there's a new one.
Yeah, we talked all about your previous one, Rising Star, in our last season. So what's going on with the new one? What have you been up to?
Yeah, so in our season break, I've been a busy bee and we have created our second planetarium film now. This one focusing on San star law, so the Tsumani San people from the Kalahari Desert in the northern part of South Africa. And we went there, we worked with the community there in collecting some of their stories about the sky, and then we've incorporated that into a film which involves a lot of the sort of general feel of the area, but then also some animation. We've animated the story just to try and get it across because it's a little bit fantastical. Is fantastical a word?
It is now. And you told me some pretty cool stories of your time up there in the Karoo filming this, and it's got to do with our new podcast art.
How did we get that far without saying we got a new art?
Yeah.
You may have noticed, or if you're a new listener, you may not have noticed, but we have a new logo, new podcast art, or a slight facelift. And yeah, on my trip to the Kalahari, I had a mission to film a planetarium show, but then I was also sent on another mission by a certain Dr. Jacinta Delhaize to get us a nice picture of the Milky Way with an acacia tree in the foreground. So one of the nights when we'd finally wrapped our shooting at 10 p.m. or something, we bundled up into the car and drove off to try and find a tree, which was great fun. We spent a few hours there and managed to get a couple of great shots, and one of them which we have now incorporated into our logo. I hope you like it, Jacinta.
Yeah, well, I love it. I really love it. I hope our listeners like it. I mean, I loved our previous one as well. It was a picture of a comet over Table Mountain, and it was beautiful, but it wasn't a savanna. And the name of our podcast is The Cosmic Savannah. So I really wanted an acacia tree because when I think of the savannah, that's what I think of. And I wanted elephants too, but Dan said no. So
Well, there's no elephants in the Kalahari. Well, not in that part of the Kalahari.
Oh, well, that makes sense then. We have to be authentic.
So I should give a shout out to the film crew who helped take this photo. Carl Jones, Jared Kaiser, and Telmo Dos Reis, who we all bundled into a car and went to take these photos. It was a super fun evening, and we got some great shots. We also saw some cool animals. No elephants.
What did you see?
Yeah, well, it was amazing because we were out there and just worrying about the stars, which were incredible, and trying to take photos of them and painting trees with light and all sorts of cool stuff. And then we climbed in the car. We were like, well, we better get back now. It's getting late. And climbed in the car, and we just started seeing these eyes on the road. And we saw a little bat-eared fox. We saw spring hares, which are like these amazing things. As an Australian, they look like kangaroos, but they're like half a kangaroo,
Aww.
half a rabbit.
Cool.
So like they're way cuter than kangaroos, naturally.
Hey.
And yeah, anyway, we don't have to talk about animals. But yeah, super fun evening, and thanks to Carl, Jared, and Telmo for that super experience and the great photo we got out of it.
Yeah, and you had an awesome graphic designer as well who helped put it together.
Yeah, and so then we handed it over to Susie Karras, who's our graphic designer, and she's worked her magic and made it look absolutely stunning.
All right, that's enough about our art. So our listeners can see that when they click subscribe, hopefully, to our podcast. Okay, so we've gotten this far. We still haven't introduced what our topic is for this episode or our guest. So let's do that now. Who do we have on the podcast today?
So today we are joined by the illustrious Professor Phil Diamond, who is the SKA director.
He is the Director General, so the big, big, big boss of the entire SKA.
The SKA organization,
Right.
as it is now
Yes.
known. So the SKA is the Square Kilometre Array, which is the telescope. And the SKA organization has now formed formally. All the countries, all the partner countries have signed. And very recently, the SKA was given the green light for construction.
Yes, that was very exciting. But before we get into that, and Phil's going to tell us all about that, Dan, do you just want to run us through quickly, for listeners who they're joining us for the first time, what is the SKA and why is it such a big deal?
Sure. So the SKA is a radio telescope, and Meerkat is a radio telescope too, a slightly smaller one, which Jacinta mentioned earlier. And a radio telescope is something which looks at radio light, so radio waves, which are coming from space, and we collect them, we combine them, and we try and make images of distant galaxies and gas and various objects out in space, which we can map with a radio telescope. Now, a radio telescope looks quite different to a regular telescope. It's a dish. In South Africa, we have these things called satellite dishes. I'm not sure if they're the same around the world to get TV, but they're a small sort of dish that sits on your roof. And Meerkat and SKA have very large ones, 15 meters across, and a whole array of them. So Meerkat has an array of 64 dishes, each 13 meters across, and the SKA will have about 200 of those, or at least in the first phase, and those will be about 15 meters across. So we're looking at a huge array of these satellite dishes sitting out in a desert somewhere and trying to collect very, very faint radio waves from across the universe.
Yes, exactly.
Well, I hope exactly.
Well, this telescope is going to be the biggest one that has ever been built in the history of the Earth. And it's really special because it's going to be built across 2 continents, right? So part of it will be built in Southern Africa and the other part will be built in Western Australia, where I come from. So essentially it's going to be 2 telescopes, 1 observatory, and the headquarters are in Manchester in the UK. And Phil's going to tell us all about that in a moment.
As you mentioned, the Australian portion of the SKA has a slightly different look, actually. So it's still an array of radio telescopes, but these are sort of wire Christmas tree things. All right, so we're going to be hearing from Professor Phil Diamond, who's the SKA Director General, and he's going to be telling us about this and more. And just a note for football fans that this was recorded a couple of days before the Euro 2020 final.
You'll hear why that's relevant. All right, let's hear from Phil.
So joining us today is the Square Kilometre Array Observatory Director General, Professor Phil Diamond.
Welcome to the Cosmic Savannah, Phil.
Hi guys, good to meet you.
Great to have you here.
Yeah, thanks for joining us. First question I wanted to get straight into. If Italy wins on Sunday, are they kicked out of the SKA?
I cannot answer that question. In my heart, I know what I would do, but no. Look, it's 55 years, mate. 55 years. And the 1966 World Cup final is the first football game I ever remember. Because we had to go and watch it at my neighbour's because my parents didn't own a TV. So it was an event for me, and that was the last time we won anything.
Sure.
I assume are we talking about some sort of football tournament?
Jacinta.
Phil's shaking his head and he's speechless.
It did discussed, yes. Anyway.
Please excuse my co-host.
All right. Okay, Phil, could you just start by telling us in your own words what is the SKA and what it means to be Director General?
So the SKA stands for Square Kilometre Array, which is somewhat of a misnomer because the square kilometre is still our aspiration for the long-term goal for the amount of collecting area that we hope to build in the next generation radio telescope, or radio telescopes, plural. But the name has been around now for nearly 30 years, and it is stuck with us. But really, what the SKA is, what the SKA Observatory is an organization that's been put together, a global organization, to design and build and ultimately operate 2 next-generation radio telescopes, each of which, in the frequency range in which they operate, will be the largest radio telescope, indeed the largest telescope on or off the Earth. So a very complex program that we're engaged in, very complex international relationships that we have to deal with. But the ultimate goal is to build 2 telescopes that will observe the universe, and each will have an enormous range of science that they will address. I hope that captures it in a few sentences.
Why radio telescopes? I mean, why 30 years ago was this the goal? Why not another science experiment? Why did this one get so big?
It was the late 1980s, early 1990s that scientists from around the world were thinking about the next big scientific challenges. And one of those core challenges, one of those that emerged, was being able to look back pretty much to the dawn of the universe using hydrogen, the most common element in the universe. By looking back through time to that dawn, to see the first stars, the first galaxies that were formed out of those stars, first black holes, and then to watch the universe evolve and develop to what it is now. One of the ways, in fact, the only way that you can follow that full evolution is through the study of hydrogen. And hydrogen has a specific emission line, which in the rest frame, that is local to our own galaxy, emits at a wavelength of 21 centimeters. If you look back in time, because the universe is expanding, that 21 centimeters grows the further back we look. But all of that sits within what we call the radio spectrum, the radio part of the electromagnetic spectrum. What we see with our eyes is a particular part of that spectrum with very tiny wavelength. Radio is at a much longer wavelength. And so in order to detect these radio signals, one needs large steel structures, such as radio telescopes, which are the radio equivalent of our eyes, but picking up radio waves instead of optical waves. So that was the goal, study the evolution of the universe, but the signal from hydrogen is incredibly weak. So in order to detect it in the time soon after the Big Bang, over the huge distances that it has to travel, the telescopes had to be huge to detect this very weak signal. That's sort of the motivation behind the journey that we set out on 30 years ago. And the design of those telescopes has now been developed hugely from those early concepts to what we're about to start constructing now.
So, Phil, you mentioned sort of the epoch of reionization studies and as to one of the main reasons why the SKA was originally sort of dreamed up. But of course, there's a lot of other science that we'll be able to do with it. And the way it's designed, it's flexible to do quite a lot of different types of science. What are you most interested in personally? I mean, I know you're not allowed to pick favorites in terms of the science goals, but, what is your background in science and what are you really interested to see what the SKA will find?
Oh, I think I'm allowed favorites.
Oh, good.
Yeah. We have our very high priority key science goals, which is understanding the epoch of reionization, the cosmic dawn, and it's using pulsars to probe fundamental physics and general relativity, gravitational waves, etc. So those are fantastic goals. They're not areas of science in which I have any expertise. I'm interested, but I don't have the expertise. The areas that I am most interested in, there's two of them. One is molecular spectroscopy, molecular astronomy. So using the SKA to understand in detail the nature of and the physics of molecules in the universe. And the SKA will have the sensitivity to detect the weak emission from heavy biomolecules, the precursors to amino acids, potentially enabling us to look for the signature of the origins of life out there in the universe. So that's one area that I'm keen on. Another is magnetism. Magnetism is, in colloquia, in seminars that are given in astronomy departments, there's always some smart ass, if I'm allowed to use that word, it's usually male, puts his or her hand up at the end of the seminar and said, have you considered the effect of magnetic fields? Because it's hard. And we don't really understand the impact, the effect of magnetic fields on the various phenomena that we observe. We can see their effects on the strong sources that we can observe right now. But again, with the SKA, because of its unique sensitivity, we'll be able to study magnetic fields in all sorts of phenomena and try to unlock how they influence the universe that we see and that we live in. Those are my two favorite areas.
That's a pretty good answer. Signs of life and magnetic fields. I actually made a bingo card once for a conference I was at, and one of the things on there was, have you considered magnetic fields? So the SKA will answer all of that. Dan, you were going to say something.
I was just going to say, so does your sort of current interests in the SKA, how did you come to be involved in the SKA? How long have you been working here, and what was your research?
So I did my undergraduate degree in physics with astrophysics, the University of Leeds in the UK, way back before you two were born. It was 76 to 79, I was an undergraduate. And then I went to Jodrell Bank, which is part of the University of Manchester, to do my PhD. And, as an interesting little connection, of course, the SKA headquarters is now at Jodrell Bank. So I've sort of had that connection through my history. But back then, the SKA wasn't even a concept.
Neither
so
were
I got
we.
interest. No. So when you did your PhD at Jodrell Bank, you either did hydrogen, pulsars, or interferometry. And I came in and I was most interested in the interferometry side of things, having built a small solar interferometer as an undergraduate experiment. So I got involved in Merlin, the multi-element radio-linked interferometer network at Jodrell Bank, and was using that to observe the hydroxyl molecule in late-type stars. So you can see why I have my interest in molecular astrophysics. It comes from those early days. I then got involved in very long baseline interferometry, which is connecting telescopes around the globe to get very high resolution observations, like a zoom lens. If you imagine a single telescope being a wide angle lens, VLBI gives you that zoom lens ability to see the detail. And if you're involved in VLBI, just because you have to talk to people at other observatories, you have to point your telescope at the same object at the same time, record your data with the same format. You have to know what time it is, of course. You get to know a lot of people. And in those early days, the software for VLBI was very limited. So I was involved in the science, but I also got involved in the software for VLBI. So I had that sort of joint science technical interest. And I pursued that for many years. And then there was this meeting the famous meeting for one might say, the birth of the SKA idea at Albuquerque, New Mexico. It was a conference celebrating the 10th anniversary of the VLA. And that's where the first paper was given that mentioned, at that time it was called the hydrogen array, which pulled together the ideas from various scientists. Now, I know I was I was employed at NRAO at that time, but I wasn't at that meeting. And it wasn't until many years later I figured out why. And it was staring me in the face. My son was born 2 days before that meeting.
Oh, wow.
So I had an excuse as to why, because I know I was at the barbecue for the meeting. My wife and I took our son on his first outing when he was just a few days old. And so for the next 10 years, I wasn't really attached. I came back to the UK in 1999, just as the SKA what was called the International SKA Steering Committee was being formed. And this was 1/3 US, 1/3 European, 1/3 rest of the world. And at that time, actually, South Africa was not part of this. It was pre the South African involvement. And they had a meeting in Manchester because the IAU General Assembly was meeting there. And I put my hand up to organise the meeting of the International SKA Steering Committee. And I was appointed to the steering committee as one of the 2 UK members. I was the director of Merlin at that time. I'd come back, full circle back to the UK. And that's how I really first got fully engaged. Of course, I knew all about the SK activities, but that's when I first got fully engaged. And then worked with various aspects. I've already talked for long enough, but the journey went on. And then in October 2012, I was appointed as Director General of the SKA organization. And then just a few months ago as the inaugural Director General of the SKA Observatory. So it was an absolute privilege to be involved in the project. It's been great.
You skipped the bit where we met in Western Australia, Phil.
Oh, yeah, well, that I should have mentioned that, Jacinta, yes. Yeah, well, that's when I was on sabbatical, though, wasn't it?
Yeah, that's right. When I was a PhD student.
That's right, yeah.
Pretty nice, though, that you've been involved from the very birth, even if you missed the birth for another birth.
Yes, that's right, yeah.
What year was that Albuquerque meeting?
1990, October 1990. My son's birthday is the 6th of October, and this paper was given on the 8th of October.
Oh, it's his birthday present then.
Pretty much, although I'm not sure he fully appreciates that.
He's not an astronomer as well?
No, he works in science communications. But actually, I don't know if you may have come across him, Jacinta.
Yeah, we've met.
Yeah.
An admirable career then.
So, Phil, you've been kind of involved in the SKA for so long, even since 1990. How does it feel to right now be on the precipice of it? Like, this thing is starting to actually be built. You announced, I think it was a couple of weeks ago, that construction is approved to begin on the SKA, finally, after all this time. How does that feel?
Well, absolutely fantastic. The actual decision was made by the Observatory Council on the 25th of June, the second day of the 2-day council meeting. There was a third meeting of the Observatory Council, which of course built on many, many governance meetings in different organizations before that. And at the start of that week, I sent out an email to all my senior staff saying, right, for me personally, this is the most momentous week of my professional career. And so let's not let anything mess it up, because it was, I would say, it was almost a done deal as we entered the council meeting. But I have enough grey hairs or lack of hair to know that something can always upset things. But luckily, we got through it all very smoothly. We ended up with a decision to proceed. And actually, 1st of July, everything kicked off. And I should say that the team are already putting out market surveys, which is the precursor to going out for invitations to tender, for companies to tender for the infrastructure work and software contracts and things like this. So we didn't sit around and congratulate ourselves. The team got right into it. They were raring to go. So yeah, it's a wonderful, absolutely wonderful feeling after all this time, to be starting down that road to construction. And it's not just me who feels that way, because we've had a team within the SKA Observatory and across all the partnership, the global partnership, that's been desperate for this decision for a long time. And I think, sigh of relief that we're finally there.
What are the big milestones? What are the future grey hairs?
Well, there's always money, of course. One has to talk about money in these big projects. And we've got a large majority of the money committed, but not all of it. So part of my job is, and I have a strategy, a funding strategy approved by the council to go out there and raise the minority of funds that we still need. So that, I'm sure, will add some grey hairs. I actually had a meeting this morning about a groundbreaking ceremony or ceremonies on the two sites. So this is something we're looking forward to Q1 of next year. It's going to be complicated, of course, by the pandemic situation, whether we can get appropriate people to the sites, with the appropriate gold-plated shovels and, and everything that you need to do for a groundbreaking ceremony. So that's another milestone.
Can we come?
I was going to say, I'll be there. I can hold a gold-plated shovel. No problem.
Yeah, absolutely. Look, these will be media events.
Yay.
So I'm sure.
The Cosmic Savannah podcast will be there.
Yeah. So that's in the short term. And then, of course, we've got various construction milestones leading all the way up to sometime in 2028 or 2029, the completion of construction. We will be starting science observations well before then, as we start to commission the SKA, get scientists involved in early science. No guarantees it'll be perfect. No instrument like this is ever perfect on day one. It takes many years to iron out all of the bugs. But we're hoping to be delivering science well before the end of the decade.
It's so exciting.
We've talked on this podcast a lot about the precursors to SKA and, Meerkat and ASCAP, the MWA. And you say that there's going to be a learning process in terms of getting these telescopes up and running. And a lot of that learning, I imagine, has already happened, which was the idea behind these precursors. And with Meerkat in particular, the SKA dishes are, if I'm not mistaken, additions to the array. Does that speed the process up a bit? I mean, is there still complications in terms of that?
Oh, no, there are so many complications because, what we're building is larger and next generation in terms of a lot of the digital hardware, the software, etc. But the precursors have been absolutely critical in terms of assisting in the whole program, not least because in both cases, in South Africa and in Australia, the precursors landed on essentially virgin sites and established and developed the sites that the SKA eventually will soon be built on. So that single aspect, they've been critical. But also, if I just focus on Meerkat, for example, and I think I pronounced it correctly, one of your previous science ministers corrected my English pronunciation of Meerkat and taught me how to say it properly. But the system engineering approach that was adopted by SKAO is something we looked at, we've learned from. The SKA dishes are not identical. They're slightly larger than the Meerkat dishes, but they're also a bit lighter, and I think they will come in as considerably cheaper. But that's because of the lessons learned through Meerkat that have been transferred to the project. It's many different aspects like that. The software, I think, is one of the key areas. The software developed not only to run Meerkat, but to process the data. That is finding its way into the SKA software. And very similar things are happening with ASCAP and MWA. Different learnings from those projects are being incorporated into different aspects of the SKA. So, and LOFAR as well in the Netherlands, and even Merlin, the eMerlin array. We've learned a lot from them on time synchronization over fiber optic systems and things like that. So, we will take our learnings from wherever we can get it.
Yeah, we stand on the shoulders of giants.
Absolutely.
So to change the topic a little bit, Phil, you mentioned that these telescopes were built sort of on virgin land in terms of the technology. But I know that you've also, the SKA organisation has been very careful to engage with the local people, the traditional owners of the land on both sites, with the Warraji Yamaji people in Western Australia and the Khoi and the San people here in South Africa. Could you mention a little bit more about that?
Sure. Well, we're extremely conscious that we're only going to be guests on these sites, guests of the governments, but also guests of the indigenous and the local communities there. And we absolutely, and we're building this into our core values for the observatory, we will absolutely be good neighbours in all respects. So, yes, we are developing those relationships with both the Warraji Yamaji and the sort of more diverse local communities in South Africa. But again, that is building on the work of CSIRO, ICRA, that's the Universities of Western Australia, and Curtin in Western Australia, and the federal government, and also SKAO, SKA South Africa, National Research Foundation, and the South African government have been doing in the Karoo. So they again have led on the path in both of those engagements. We have watched and learned very carefully. We're now getting engaged ourselves, but we'll continue to work with both SKAO and CSIRO and ICRA, of course, in those future engagements. So it manifests itself in several ways. Where possible, we want to engage with local companies in terms of construction contracts. There will be numerous contracts for the ongoing operations, maintenance services and things like that. So we want to be a good neighbour and make sure we work closely with the communities. We want to get involved in outreach and educational activities and things like this. So, we have a lot of thinking, a lot of planning around this, and we do watch and learn from other unfortunate experiences elsewhere in the world. That's not the reason we're doing it. We were determined to do this, before all of that happened. Yeah, it's right at the heart of what we are as an observatory.
Yeah, absolutely. It's something we feel very passionately about too. I mean, both at the observatory and then personally. It's really something which is pivotal to any sort of interactions going forward, and something which astronomers really need to take consideration of in all of their activities. I think on that note, what considerations are being taken with regard to the SKA in terms of climate and sort of environmental impact?
Yeah, well, that's another aspect. So as well as being good citizens locally, we need to be good citizens globally. And every aspect of what we've been trying to do in terms of designing the telescope, we've been looking at long-term sustainability. Now, that's driven by two reasons. One is that sort of global good citizen aspect, but the other is more pragmatic. We can design low devices that use low power, are relatively cheap and long life, then that assists us in terms of our costs, but also moves towards sustainability. we don't have to replace systems as often. So we've taken good account of this in the design activities. Both of our sites are remote necessarily because they have to be away from people for radio quietness. So power has been a big issue. And I have to say that 10 years ago, power was one of the top things in my risk register. It really worried us how we were going to get the level of power we needed. So first of all, in our design, we reduced the power requirements of the SKA by a factor of 2 through these design efforts. So that helped, but it didn't solve the problem. But in the 10 years since we started the design activities, the solar power techniques and systems and technology has improved vastly. And also battery backup systems. And the cost has come down, so it's now affordable. So the whole of the site, the SKA Low site in Western Australia, will be powered by solar power with battery backup. We will, of course, have to have diesel generators as the final backup, but we don't anticipate using them in any routine sense at all. I mean, to ship diesel 350 miles out into the Murchison is a ridiculous thing to do. And similarly in South Africa, we are connected to the grid, and we will be looking at making sure the power coming in is as green as it can be. But we're also putting solar PV stations in for some of the more remote dishes in the SKA mid-array. And we're looking at a longer term future, which might have solar PV for the whole of SKA mid. That's something that's being looked at. It's not a certainty yet.
That's awesome. I guess astronomers know almost better than a lot of people that there is no planet B. You know, we see a lot of science fiction, but, you know, we're looking. That's part of what the SKA will do, is looking for other habitable kind of planets. And we know that there just isn't one. This is it. And so we do have to take care of it. And also our South African listeners will be well aware of the power problems that we have here in South Africa. We have load shedding all the time, which is regular power outages. Yeah. So I guess, you know, you wouldn't want the SKA to be affected by that. So I guess you have to have these backup power options.
Yeah, no, that's exactly the case. We're well aware of the pressures on Scom, on the South African power infrastructure, and we don't want to add to that. I mean, we're not going to be a big user in terms of some industries and populations, but still, cost is a driver, but also sustainability is a driver. And solar PV systems now are very large-scale systems, very comparable in cost to, you know, the traditional fossil fuel generated power, if not cheaper. So it's a sensible way to go.
Yeah, and it's presumably only going to get better as we get into second phase and stuff.
What is the difference between phase 1 and phase 2 of the SKA, and will other African nations be involved in phase 2?
So phase 2 it's our long-term goal. It's a true aspiration. And it's not something that's fantasy, because I have government members who are always, not always, but do ask me on occasion, what is the timetable for phase 2? Do you have a cost estimate? We've given them a cost estimate, which is large, based on concept engineering studies. And the time scale is definitely after phase 1. Governments want to see that we can build the first phase, because what our plan is for phase 2 is something that is of order 10 times larger. So maybe 2,500 dishes across Southern Africa, not just South Africa, but Southern Africa all the way up to the equator. And similarly, a large expansion of the SKA Low in Australia. And so necessarily, if we, in Africa in particular, if we spread across the southern half of the continent, we will need to involve and engage with other Southern African countries. The South African government has strong links and connections and arrangements with 8 Southern African countries. And they're not formally part of the SKA Observatory, but at the time that we expand, we'll have to talk to them, bring them into the observatory in some form. But that's for the next Director General. That's not going to be my job.
Dan and I might throw our hat into the ring.
Oh, I don't know. I quite like the color of my hair. I was about to ask on that. I mean, you've presumably had a lot of experience in now international diplomacy. It's a hugely international project with many international partners. And the current era, there's increased nationalism and issues like that. Something like the SKA, do you see it as a sort of vessel of peace or some way to bring countries together?
I do. I honestly do. It's and projects like it, because we're not alone. In global scales, we're relatively small scale activity compared to many of the other things out there. But what it does is it brings a diverse range of countries, government officials from those countries, scientists from the countries. They sit around the table and they solve problems jointly. They work together. They provide resources to the project. And it's like the analogy I gave with very long baseline interferometry earlier, where we had to get telescopes to record data in the same format at the same time from the same object. Here, we have to have dishes built in one country, integrate with software developed elsewhere, and receivers from another country plug in, and the whole package has to work seamlessly. So we're working on a very detailed level with scientists and engineers and companies in those different countries. And then on a governance level, all of the countries, once they are members, they get an equal voice in how all of this happens. They get to guide the policy. They get to work together. And so a project like SKA and ITER, the big nuclear fusion power project in southern France, space agencies and things like this, these are all key elements in governments that might have trade conflicts, even much more serious conflicts happening. They continue to work together, and I think it helps. Do you know the project Sesame?
No.
You should look it up. This is a fascinating project. So it's a small-scale accelerator built in the Middle East, and it has countries like Jordan, Egypt, Israel, Lebanon, Syria, etc., involved doing science on this accelerator, the synchrotron. I think it's a synchrotron accelerator. It's purely civil science. But these countries that, in other regards are in serious conflict are working together on a scientific project. And it's things like this that are wonderful. Very long baseline interferometry in the 60s was one way in which the Soviet Union and the Western powers, primarily the US, engaged in low-level dialogue through scientific exchanges. And I'm not saying it caused the wall to come down, but it was one element of that sort of soft diplomacy, that connection between countries. So I feel very passionately about this, as I hope you can tell from what I was saying.
Yeah, that's really awesome, Phil. And we say this on the podcast all the time, but we're all under one sky, and that's really what unifies us as humans on this planet. We're all under one sky, and so the SKA telescope can, really unite us in its findings because it belongs to all of us, really. So, Phil, before Dan and I consider applying for your job when you're ready to move on or retire, tell us, what actually does it mean to be Director General, and what do you do as part of this role, and how does it feel?
Well, it's a wonderful job. It's the best job I've ever had, and it's a privilege that the board previously and the council have trusted me to have this role of Director General for 10 years or so, and actually to continue for a while longer. What do I do? Well, I spend a lot of time, pragmatically daily, a lot of time on the phone, on email, and more over the last year on Zoom. A lot of it is about communication. There is that diplomatic aspect, and it's staying engaged with the senior stakeholders in the various partner countries, because they all come at it with slightly different perspectives, slightly different goals, depending on their national situation, their national agendas. And it's pulling all of this stuff together to make the whole thing work. And then to work with my team, Joe McMullen, my deputy, who runs what we call the program, the technical activities. Simon Berry, who is the main person looking after international relations, and then Caroline Whiteley, who runs the finances. They're just three members of a broader team that I interact with also on a daily basis to make sure the mechanics of things are working smoothly. Because if there's a problem there, I often have to get on the phone or email with one of the governments to try and sort out particular things. And sometimes there are conflicts to resolve. Sometimes I have to take decisions that some people are unhappy with, but you have to move the project forward. And the secret is maintaining the relationship even when a tough decision has to be made. And yeah, sometimes it's hard, but I sleep well at night generally because I know we're doing the right thing here and that the project's moving forward.
Thank you once again for your time and for explaining your view on the SKA and the experience it's been for you. I think just taking us on that journey has been very special. The journey will be passed on now to the younger generation, and perhaps you have a couple of messages or to the listeners or to the younger generation as to how to take this forward and what you'd like to pass on.
Well, first of all, I wish I was 40 years younger and just starting out on my career, because I don't know, you may have heard me say this in talks I give, but I am envious of what the future is in astronomy and science in general for the younger generation. The facilities, the techniques that will be available to them are truly wonderful. So if I was in that situation and looking to be engaged in a project like SKA, I mean, first of all, it's for the scientists, it is the science. I mean, choose your subject well. I would say don't confine yourself to an area that limits you to one telescope or one facility. You should be looking at the world of astronomy and the various facilities that are available to you, and be bold. Be bold in the ideas that you have. But make sure you've got the right skills. So it's not just the physics or the chemistry or the astrophysics side of things. These days, it's very much understanding the data as well. The data science is a key element of what the younger generation will be involved with, much more so than my generation. We thought we were overwhelmed with data. That's not the case. But also the skills that the younger generation will gain in preparing for these things will also serve them if they decide to move on elsewhere in society, because society is becoming data rich, and somebody skilled in data informatics and things like that will be able to get a job anywhere. But, above all, I don't know how many of what age profile your listeners are, but stay at school, do the tough subjects, the maths, the science, the engineering, the technical stuff. It's fun and it's easier than you think it is. It also opens up a whole world, I think, of opportunity, which is really what we're all after. We want a fair crack of the whip at the opportunities in front of us. So, yeah, maybe that's my message to the young listeners. Sorry if I sounded as though I was preaching a bit.
Not at all. Thank you so much, Phil, for that. And I'm hoping that you've inspired many a young listener to get involved in STEM subjects and get involved with the SKA. Where can our listeners find out more? How can they follow you on social media and learn more about the SKA?
So I do have a Twitter account, which is I tend to keep fairly factual. There may be the occasional football comment on there.
I follow you.
At SKA_DG. Of course, the SKA Observatory has its own Twitter, Facebook, Instagram, YouTube accounts. We also have a website which is currently being revamped from the ground up. The website's 10 years old now, and we've taken the opportunity of moving across to the SKA Observatory to revamp that. So I don't know what the new website URL will be, but the current one is skatelescope.org. I'm told the new website will be exciting.
Yeah, thank you so much for joining us, Phil. I mean, really some inspirational words and really special to hear from you. One last question from me is, have you considered magnetic fields? Sorry, I couldn't resist.
Lame! Dan,
Wait
lame.
10 years. Wait 10 years.
All right, thank you so much, Phil, and this has been really awesome to talk to you. Thanks for joining us on the Cosmic Savannah.
No, thank you. I've enjoyed it.
Okay, so the awkward news is that Italy won on penalties.
Oh dear.
I mean, I haven't checked the news since. Like, I don't know what's happening with the SKA.
Is Italy still in? We jest. Of course they're still in.
But yeah, I mean, great to chat to Phil. I mean, really a momentous achievement to get the SKA to this point. We've been talking about it for years. He's been talking about it for decades. And for it to finally be in construction. And I mean, in my email, I'm seeing the tenders going out for people to build infrastructure and roads. And it's really, really happening now.
Oh, that's hectic.
Yeah. So, I mean, just an incredible achievement. It is going to be a very, very exciting telescope and experiment for many, many years to come. But yeah, great to speak to Phil and to mark this occasion. I think that we should all be very proud of how far we've come in the astronomy community.
Oh, and I can't wait to see where we're going. It's going to be so exciting. All right. Well, this episode's long enough, so I think we can end it there. And we will be back in a fortnight, hopefully, with some more cool stuff coming from Africa.
Yeah. Thanks again very much for listening, and we hope you'll join us again on the next episode.
You can visit our website, thecosmicsavannah.com, where we'll have the transcript, links, and other stuff related to today's episode.
You can follow us on Twitter, Facebook, and Instagram at Cosmic Savannah. That's Savannah spelled Savannah.
Special thanks today to Professor Phil Diamond for speaking with us.
Thanks to our social media manager, Sumari Hatting.
Also to Mark Olnut for music production, Jacob Fine for sound editing, Michal Wurczek for photography, Carl Jones for astrophotography, and Susie Karras for graphic design. We gratefully acknowledge support from the South African National Research Foundation and the South African Astronomical Observatory, as well as the University of Cape Town Astronomy Department. You can subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts, and we'd really appreciate it if you could rate and review us and recommend us to a friend. And we'll speak to you next time on the Cosmic Savannah. It's really, really happening now. That's hectic. Yeah. Is hectic a South African term? I was trying to impress you. You've become South African. I was trying to impress you. I was like hearing you say it. I was like, what? Oh my gosh, you coming across to our side. I've been here for a while, Dad.